Hello, we have a set of 31 problems for the second week. I start with problem number 1. For the following polynomials, identify the degree, the leading term, and the leading coefficient. Okay, the first one, so this was problem number 1. The first one is negative 4x, negative 7, negative 4x2. Okay, well, first the degree. The degree is the highest degree of the variable. So x2 is the highest degree because this is x, this is 1. So x2, so the degree is 2, the highest degree. And then the leading term. The leading term is the term that has the highest degree. So the leading term will be negative 4x2. And then leading coefficient. The leading coefficient is the multiplier of the highest degree. So if this is the leading term, the leading coefficient is negative 4. Now we go to second question. 16x3 plus 9 plus 6x7. So the degree is the highest degree, 7, right here. The leading term is 6x7. And the leading coefficient is the multiplier of the highest degree, so it is 6. The next question is 6x20 minus 7x13 minus 9x17. So the degree is the highest degree. So 20 here, 13 here, 17 here. So the highest degree is 20. So the degree is 20. And then the leading term is 6x20. And the leading coefficient is multiplier of the x20, so it is 6. Okay, so this was problem number 1. Problem number 2. Number 2, evaluate minus 3/2 x4 plus 7 squared minus 4x. 4 for what value of x? For x equal 2. If needed, round your answer to 4 decimal places. Okay, so 2, if x is 2, you put 2 instead of x everywhere. So negative 3/2 times 2 to the power of 4 plus 7 squared minus 4 times 2. So this will be 2 to the power of 4 means 2 multiplied by 2 4 times. So 2 by 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So we have negative 3/2 times 16 plus 7 squared is 7 times 7, 49, minus 4 times 2 is minus 8. So we get simplifying 16 and 2, so this is 1, this is 8. I divide 16 by 2. Negative 3 times 8 is negative 24 plus 49 minus 8. And all these together, I can check negative 24, negative 8 is negative 32. 49 minus 32 is 70. So this is the final answer. Okay, this was problem number 2. Let's do problem number 3. Find the sum. We have an addition of two polynomials. We want to find the sum. So I rewrite 40x5 plus 44x cubed plus 41 plus 68x5 plus 17x cubed plus 24. Okay, so we want to find the sum. We have one polynomial here, we have another polynomial here. We want to find the sum. We add similar sentences. So what sentences are similar? We have x5 here, x5 here. So these two are similar. So 40x5 plus 68x5 is 40 plus 68. It is 108x5. Like you say, I have 5 apples plus 4 apples, it is 9 apples. So 40x5 and 68x5 is 108x5. And then we have 44x cubed plus 13x cubed. So we add 44 and 17, which is 61x cubed. Plus 41 plus 24 is 65. So this is the final answer. Okay, this was problem number 3. Okay, now we do problem number 4. You use FOIL to find the product. So, number 4, 4k plus 3 times minus 7k plus 4. I don't know what the FOIL is. It should be a rule, but I teach you how to multiply these. In order to multiply, you need to multiply all sentences on the first parenthesis by all sentences in the second parenthesis. So start with 4k. 4k times negative 7k is negative 28k squared. Because 4 times negative 7 is negative 28, and k times k is k squared. Now 4k times 4. So it is 4 times 4, 16k. Now we go to sentence 3. 3 times negative 7k. So it is minus 21k. And 3 times 4 is 12. Now simplify. So minus 28k squared is just the only second degree. And then 16k minus 21k is minus 5k plus 12. So this is the final answer. Maybe you can check your textbook to understand what FOIL actually is, but this is how we usually find the multiplication of two statements. This was number 4. Now go to number 5. Number 5, find the product 2x plus 5 times minus 3x2 plus 9x minus 5. Okay, here this is similar to problem number 4, the previous problem. Again, we find the multiplication of all sentences of the first parentheses by all sentences of the second parentheses. Start with 2x, multiply 2x by all of these 3 sentences here. So 2x times minus 3x2. So 2 times negative 3, negative 6. X times x2, x3. And then 2x times 9x. 2 times 9, 18. X times x, x2. 2x times negative 5. 2 times negative 5, negative 10. And only 1x. Now we go to second sentence in first parenthesis. So 5 times negative 3x2. It is minus 15x2. 5 times 9x plus 45x. And then 5 times negative 5, negative 25. Now add similar sentences. How many x cubed do we have? X cubed, x2x, x2x, and 1. So only 1, negative 6x cubed repeats. And then 18x2 minus 15x2. 18 minus 15 is 3x2. And then minus 10x plus 45x. So it is plus 35x. And only 1 negative 25. So this will be the final answer. Okay, that was problem number 5. Now let's go to problem number 6. Okay, number 6. Use synthetic division to divide. X cubed plus 5x2 plus 15x plus 29 by x plus 3. Okay, we draw these. So we draw a line like this. We put the coefficients of the first polynomial. 1, 5, 14, and 29. These are exactly the coefficients of the divider, the dividend. And then we have x plus 3. So I put 1 here, because x plus 3, the coefficient of x is 1. And then we do what? Oh, okay. We put 3 here, the other coefficient. So, and then we move 1 here, and then 1 times 3, 3, 5 minus 3, 2, and then 2 times 3, 6, 14 minus 6, 8, and then 8 times 3, 24, and then 29 minus 24, 5. So the dividend is the quotient. The quotient is this polynomial here. So x2 plus 2x plus 8, and the remainder is 5. Okay? Now let's go to problem number 7. Okay, problem number 7. Divide x2 plus 1x minus 20 divided by x minus 4. Okay, so the previous problem was a synthetic problem. This problem is just direct division. So I write x2 plus x minus 20 divided by x plus minus 4. Okay, x2 divided by x is x. Now multiply x by x minus 4. So x2 minus 4x. And then subtract the second polynomial here. x2 minus x2 is 0. X minus minus 4x is x plus 4x. So it is 5x. And then minus 20. 5x divided by x is 5 plus 5. Now multiply 5 by the whole divisor. So 5 times x, 5x, minus 20. So there subtract 5x minus 5x, 0. Negative 20 minus negative 20 is 0. So the remainder is 0. So the answer for this will be, this is the quotient, x plus 5 and 0, no remainder. So maybe we can write x again. So this is equal x plus 5 plus 0 over x minus 4. This was problem number 7. Now let's go to problem number 8. Problem number 8 is another division. divide x2 plus 11x plus 31 over x plus 6. Again, we use the usual division, not synthetic. x2 plus 11x plus 31 divided by x plus 6. So x2 divided by x is x. Now multiply x by x plus 6. So we get x2 plus 6x. And then subtract x2 minus x2 0. 11x minus 6x is plus 5x. And then also transfer 31 to the second part, second line. Now 5x divided by x is 5. And then multiply 5 by this divisor. So 5x plus 5 times 6, 30. So 5x and 5x the same, so subtraction is 0. 31 minus 30 is 1 plus 1. So the quotient is x plus 5 and the remainder is 1. So I can write it this way. X plus 5 plus 1, 1 is the same one here, over x plus 6, and x plus 6 is the divider. Okay, this was problem number 8. Let's go to problem number 10. Write the following in interval notation. If no solution exists, enter no solutions. Use reduced fraction in your answer. No decimals. Okay, what is the following? So it is number 9, x less than or equal 1 and x greater than or equal -3. So start with this, x less than 1. So if this is 1, so this is an upper limit for that. So, but it can be equal 1. So this is 1 here, 1 including 1. And then for the other part, this is x greater than or equal -3. Fortunately, -3 is less than 1, so we can write it at the left of 1. And then it needs to contain everything more than that. So it comes to everything equal -3 or greater and less than 1. So this will be the interval notation of this interpretation. Okay, let's go to problem number 10. Okay. Number 10. Graph this inequality. X less than 3 and greater than negative 3. Okay. This is the number line. This is the origin. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Okay. X must be greater than negative 3. This is negative 3. So since it cannot be equal, I put a hole here. And must be greater than that, so to the right. And then must be less than 3. Since it is not equality, I put a hole. So everything between these two is the answer. So I highlight these. So this is the answer. Okay, that was problem number 10. Now let's do problem number 11. Write the following in interval notation. Number 11, 21 greater than x, or 26 less than x, or. This is not and, this is or. So x greater than 21. So if this is 21, everything greater than that. So 21x and positive infinity. It means that it contains everything greater than 21. Or greater than 26. And or means union. 26 and positive infinity. So this means that either it should be either greater than 21 or greater than 26, or one of them. So since 21 is less than 26, the union of these two is just equal to 21 and 26, because greater than 21 contains greater than 26. So this is the final answer. Okay, that was problem number 11. Let's go to problem number 12. Okay, problem number 12. Solve for z. Z plus 6 greater than 16, or 6 minus 3z greater than 15. So we need to solve each one of these inequalities one by one, and then find the union. Or means union. So subtract 6, so z greater than 16 minus 6, so z greater than 10. Or, what's this the second one? Subtract 6, So minus 3z greater than 15 minus 6, 9, and then divide by negative 3. And since this is negative, change the direction. So this is this to the left and we go to the right. So z less than 9 divided by minus 3 minus 3. So this or this. So in the number line, if this is 0, z greater than 10. So if this is 10, so everything greater than 10. This is this part. And then z less than negative 3. So if this is negative 3, less than negative 3. Okay, so this or this means together. So together is, which one is the answer? Z less than, no, part 1 is not correct. Part 2 is not correct. Part 3 is not correct. And part 4 is the answer. So part 4 is z greater than 10 or z less than negative 3. This is answer 4. Okay, let's go to the next question. Okay, simplify the inequality. Graph it, write it in interval notation, and then inequality notation. Write your answer in interval notation. So what is the problem? 2x plus 4 less than or equal negative 10, and 5x minus 10 greater than 0. Okay, the first one is simplify. Okay, simplify is almost the same as solving. So 2x subtract 4 less than negative 10, negative 4, negative 14, and then x less than or equal negative 14 divided by 2, negative 7. And then or the second one, add 10, so 5x greater than 10, and then divide by 5x greater than 2. So this or this. Graph it. Okay, graph on the number line. X less than negative 7, if this is 0 and this is negative 7, it can be equal, I put a full point. Okay, here, and then x greater than 2, so this can be about 2, and this cannot be equal. This is equal, this is not equal, so a whole. So this is the graph. Write it in interval notation. So interval notation is less than negative 7, so, and equal. Bracket means it can be equal. Parenthesis means it cannot be equal. So the lower limit is negative infinity. And then or means union, and x greater than 2, and it is not equal. So parenthesis means not equal, and then positive infinity. So this is interval notation, and then inequality notation. Okay, this is inequality notation already written. write your answer in interval notation. So it is repeated. Okay, so this is the simplification and solution. This is the graph. This is the interval notation, and this is the inequality notation. Okay, let's go to next problem. That was number 13. Let's do number 14. Number 14. Simplify the inequality, graph it, write it in interval notation, and then inequality notation, write your answer in interval notation. So what are the inequalities? 3x plus 5 less than or equal negative 19, or 4x plus 5 greater than 13. Okay, simplify. So 3x subtract 5, negative 19 minus 5, negative 24, and then divide by 3, x less than or equal negative 8. Or from here, 4x subtract 5, 13 minus 5, it is 8, divide by 4, so x greater than 2. So these are the inequalities. Graph it. Graph it is something like that, and if this is origin, and then we have x less than negative 8, this to be negative 8, it can be equal, so it should be a full point. So this is for the first inequality, and then greater than 2, so this can be 2, and this is not equal, so a whole. So this is the graph. And then write in interval notation. X less than or equal negative 8. Negative 8, it can be equal, so a bracket, so minus infinity, because it's less than that. Or greater than 2, so it is not equal, it is only strictly greater, 2 and plus 20. Okay? And then inequality notation is already done. Write answer in interval notation. It is already done, and it is union. This or that means union. Okay, that was problem number 14. Now let's go to problem number 15. Okay, the same question with different numbers. So number 15, and this was number 14. 5x plus 4 greater than or equal minus 41. 5x minus 45 less than 0. Okay, so subtract 4 to cancel this 4, so 5x greater than or equal minus 41 minus 4 minus 45, divide by 5, so x greater than or equal negative 9. At this time it is AND. Let's see what's the difference between and OR. Now add 45, so 5x less than 45, divide by 5, x less than 9. Okay, so x greater than, so now we graph it. These and these together at the same time. So if this is 0, this can be negative 9, and if this is less than 9, okay, this is 9. So greater than negative 9 means this way, and less than 9 means this way. So it should be a full point here, an empty point here, and greater than negative 9, and less than 9, not more, only here. Okay, so this is the graph of this AND. And then in interval notation. Interval notation means that x less than 9, so if this is 9, and I don't put negative infinity here because we have a lower limit. So the lower limit is negative 9. So less than 9 and greater than or equal negative 9. So this is the interval notation for this interpretation. Okay. And the inequality notation is this: x less than 9 and greater than or equal negative 9. Okay? That was number 15. Let's do number 16. Solve the inequality, graph it, write it in interval notation, and then inequality notation. So same kind of question with different numbers. 5x plus 3 less than 33, and 3x plus 5 greater than 8. So subtract 3, 5x less than 30, divide by 5x less than 6, and 3x subtract 5 greater than 3, divide by 3x greater than 1. Okay, so now the graph. If this is origin 0, x greater than 1, this can be 1, so it cannot be equal, so a whole and empty point to the right, and then less than 6, so the upper limit is 6, and it cannot be equal again, so an empty hole. So this is between 1 and 6, greater than 1, less than 6. And then in interval notation, so greater than 1 and less than 6. This is the lower limit, this is the upper limit. And then in inequality, so x between 1 and 6. Okay, this was problem number 16. Let's go to problem number 17. The same kind of question. This time maybe even easier. So number 17, x less than 10, x greater than or equal 5. This is simplified already. So the graph is this. X less than 10, if this is origin, this is 10, x less than 10, and greater than or equal 5. This can be 5, so equal means full point, and less than 10, empty point, and everything in between. Between 5 and 10. So bracket 5, comma, 10, parentheses. So it means that greater than or equal 5 and less than, just strictly less than 10. And the inequality is x greater than or equal 5 and less than 10. Okay, that was number 17. Let's go to number 18. Solve for x. What is the inequality? It is minus 15. This is number 18. Minus 15 less than or equal 5x plus 13 less than 15. Okay. We need to somehow separate variable and numbers. So if we can get rid of 13, 5x is just a variable multiplied by a coefficient. So subtract 13 from all three. One, these, and these. So minus 15 minus 13 less than or equal 5x plus 13 minus 13 less than 15 minus 13. You see that minus 13 is repeated on all three. So minus 15 minus 13 is minus 28. And then these two cancel. So 5x here. And then 15 minus 13 is 2. And then it says solve for x, so we need to write in interval notation. So now divide everything by 5. Since it is positive, the directions just don't change. So minus 25, 28 fifths less than or equal x less than 2 fifths. So this is the inequality notation for the answer. And then we are asked for interval notation. So interval notation is bracket because we have equality here, minus 28 fifths, and then 2 fifths for the upper division, so 2 fifths, parentheses, because this is not equal. Okay, so this was number 18. Let's go to number 19. Number 19. For each point on the graph above, select the correct location from the drop-down list. Okay, I don't have the drop-down list, so I just give you the coordinates of each point. Number 19, point A equals point A. It is 1 units in x direction, so it is 1, and 1, 2, 3, 4. 4 units to y direction. And then B. B is 2 units in x direction and negative 4 units in y direction. And then C. C is just origin, so it is 0 and 0, no x and no y. And then D. D is no unit in x direction and 1 unit in y direction. And then E. E is 1 unit in x direction and 0 units in y direction. And then F. It is negative 4 units in x direction and 1 unit in y direction. And then G, the last one, it is negative 4 units in x direction and 1 unit in y direction. Let's go to number 20. Number 20, identify the points from the graph above. Okay, so what are the coordinates of A, B, C, and D? So A is 1 unit in x direction and 4 units in y direction. B is negative 1 unit in x direction and negative 4 units to y direction. And C is negative 4 units in x direction and 0 units in y direction. You see that is the same as origin, same vertical distance from the x-axis. So it is on the x-axis. So D is 1 unit in x direction and negative 1 unit in y direction. Okay, this was number 20. Let's go to number 21. Okay, number 21. Plot the following. So we have 1, 2, 3, 4, 5 points we want to plot. So 4 and -2, 0, 4, -2 and 3, -1 and 0, -4 and -3. Okay. So we draw the graph. We have 5 units in each direction. Okay, first one, 4 and -2. So x direction is 4. 1, 2, 3, 4. You see that this is x coordinates, x axis, and this is y axis. So 1, 2, 3, 4. So here. And then -2 units in y direction. So from here go 2 units down. So this is first point. Point number 1, or I call it A. So it should be A. And then point B, 0 in x direction. So it is no left or right, just here. And 4 units in y direction. 1, 2, 3, 4. So this is B, or B. And then -2 and 3. -2 units in x direction, 3 units in y direction. So this will be C. 2 to the left, 3 to the top. So C. And then -1 units to the left, in x-axis, and no up or down. So 0 means no up or down. So this is point D. -4 and -3. So 1, 2, 3, 4 means -4. And -3 means down. 1, 2, 3. So this will be the last point. Okay, that was problem number 21. Now let's go to problem number 22. Problem number 22. Part 1. Evaluate the following linear equation for the given values. Okay, so evaluate means check what are the values at that point. So I draw this table. This is x. This is y equal -4x minus 3. X, the first value for x is -5. So if x is -5, what is -4x minus 3? That is -4 times -5, that is 20, minus 3 is 17. I repeat, -4 times -5 is 20, minus 3 is 17. Then it can be -1. -4 times -1 is 4. 4 minus 3 is 1. And then next value for x is 2. -4 times 2 is -8. -8 minus 3 is -11. The last value is 4. -4 times 4 is -16. -16 minus 3 is -19. Okay, part 2. Graph y equal minus 4x minus 3 on the coordinate plate below. Okay, we draw a coordinate system. So this is origin, this is x-axis, y-axis, and we plot these points because these are on the equation. These are the answers for the equation, so they are located on the line that shows this equation. So negative 5 and 17. So I assume that this is negative 5 and then 17. So this is 5, 10, 15, 17. So it is almost here. This is first point. This is 5 and negative 5 and 17. And then negative 1 and 1. So negative 1 is here and 1 is here. So this is the second point. And then the third point is 2 and negative 11. So this is 2 and negative 11 can be 5, 10, 11. So this is the third point. By now we have these, and these on the line. And then 4 and negative 19. So this can be 4 almost. So 4 here and negative 19. So 5, 10, 15, 20, 19. So 4 here. Okay, we got 4 points. We want now to draw the line. So we want start from here, pass through all these points. So this is y equal negative 4x minus 3. Okay, that was problem number 22. Let's go to problem number 23. Determine whether each ordered pair is a solution of the given linear equation. Okay, 23. The line is 6x, or this given linear equation. 6x plus 1y equal 3. So for negative 2 and 15. So x is negative 2 and y is 15. So we put these numbers in this equation. So 6 times negative 2 plus 1 times 15. So it is 6 minus 12 plus 15. 15 minus 12 is 3. So 3 is the same number. So it is correct. This point is on this linear equation. And then 0 and 4. 0 and 4. So x is 0. 6 times 0 plus 1 times 4 equals 0 plus 4, it is 4. So this is not correct. 4 is not 3. So this is not on line, not on the, not a solution. This is solution. Not solution. The third one is 5 and negative 27. Okay, 6 times 5 plus 1 times negative 27. So it is 30 minus 27. It is 3, correct? So it is a solution. Okay, that was problem number 23. Let's go to problem number 25. Okay, problem number 24. We have a graph. It says identify the intercepts of the graph. So x-intercepts. Write answers as ordered pairs if more than one. Separate with commas. Enter answers in any order. X-intercept means the point that the line passes through the x-axis. So if this is x-axis, this will be y-axis. And this point is where the line passes through the x-axis. So this is 1, 2, 3, 4 units negative 4 in x direction, and no units in y direction. Negative 4 and 0. So this is x-intercept. And then y-intercept is where the line passes through the y-axis. So it is 1, 2, 3, 4 in y direction. So this is 4. So it is 4 here. And then no left or right, so 0. 0 and 4, and this is y-intercept. Okay, this was problem number 24. Now let's go to problem number 25. We have a line, negative x plus 5y equal negative 5. So it has an x-intercept. We need x-intercept and y-intercept. Before doing that, on this graph, I want to explain you that y-intercept is where x is 0, and x-intercept is where y is 0. So if x is 0, then we will have negative 0 plus 5y equal negative 5. So this is just 0. So 5y equal negative 5 divided by 5. So y equal negative 1. So 0 and negative 1. This is no left or right, so it and y-axis. So this is y-intercept. And then y equals 0, we will have negative x plus 5 times 0 equal negative 5. So it will be this 0. So negative x equal negative 5, so x equal 5. So 5 and 0 is x-intercept. Okay, using the intercepts from above, draw the graph of the line. Okay, so I draw here. So this is continued on top. Graph. We have two intercepts, 0 and -1, 0 and -1 here. This is 1 point on the line. And then 5 and 0. 1, 2, 3, 4, 5. So now I connect these two. Okay, so this is the line minus x plus 5y equal -5. That was problem number 25. Let's go to problem number 26. Problem number 26 says that find the intercepts of y equal 3/2 x plus 3. Using the intercepts from above, draw the graph of this line. Okay, so again, x equals 0, then y equals, this vanishes, so y equals 3. So it will be 0 and 3. And so since this is on y-axis, this is y-intercept. And then for x-intercept, y0, then this is 0. 0 equals 3/2 x plus 3, or 3/2 x equal -3, subtract 3, and then multiply by 2, divide by 3, so x equals -6 divided by 3, -2. So -2 and 0 is x intercept. Now we want to graph this line. So we have 2 points. By 2 points we can draw a line, 0 and 3. So no left or right, just 3 units up. So this is 3, so this 1 point, and then -2 in x direction, and no movement in y direction. So this is -2. So connect these two lines. So this will be this line, y equal 3/2 x plus 3. Okay, let's go to the next problem. number 27. From the graph below, write the shaded region in inequality equation. Okay. You see that this is a line that's on top, it is red shaded. So first, let's find the equation of the line. So it is the x-intercept is 2 and 0, and y-intercept is 0 and 2. Okay, so if you assume that this is y equal mx plus b, if we put x0, we get y equal 2. So mx plus b, so y equal m times 0 plus b. So this is just minus, so y equals b is the y-intercept. So b is 2 here. So y is 2, excuse me. Y is 2 and y is 0, x is 0. So b is 2, so we have y equal mx plus 2. And then also 2 and 0 is another point. So 0 equal 2m plus 2, or 2m equal minus 2, or m equals negative 1. Okay, so the equation of the line is y equal minus x plus 2. So because of the continuity of the plane, one side must be the answer and the other side must not be the answer. We see that this part, the red shaded part, is for bigger y's. So we are looking for y greater than negative x plus 2, because it is toward the higher y's. And this is not equal because the line is not full shaded. Okay, this was problem number 27. Let's go to problem number 28. Graph y less than x minus 1. I want to teach you how to graph this kind of problems. First, assume that this is an equality. So y equal x minus 1. So draw this line. So y equal x minus 1. If x is 0, y is negative 1, and if y is 0, you can easily see that x is 1. So these are y-intercept and x-intercept. So 0, negative 1, 0, negative 1, and then 1 and 0. This is y-intercept, this is x-intercept. And by connecting these two, we see that this is the line y equal x minus 1. And then this is y less than something. So it is for y towards negative infinity. So the answer will be this part. And then since this is not equality, this is half shaded. This is not full line. It does not contain the points on the line. Okay? So this region, I'm not including the line. Okay, that was problem number 28. Let's go to problem number 29. Okay, another graphing problem. 29, y less than or equal to x plus 2. Okay, again, assume that this is a line, y equal to 2x plus 2. And then find the y-intercept and x-intercept. So if x is 0, y is easily 2. And if y is 0, and then x is negative 1. So negative 2 plus 2 is 0. Now draw the line. So 0, 2. This is the first point. Negative 1 and 0. This is the second point. And this contains equality. So we can keep the line as full shaded. Okay, this is the line, and then y is less than something, so it goes towards less y's. So it is this part. Okay, and this is y equal to x plus 2. Okay? If it was y greater than 2x plus 2, then it goes to upper y's. Okay, this was problem number 29. Let's go to problem number 30. Use the graph to determine which ordered pairs plotted below are solutions of the inequality. Okay, so the shaded part is the ones that are the solution of the inequality. So, for example, -1 and 3 is in shaded part, so it is a solution of the inequality. But -4 and -1, it is not in the shaded part of the inequality. So it is not a solution of the inequality. Also, 3 and -2 is in shaded, so it is a solution. Also, 1 and -3 and 2 and -4 are in shaded part, so they are also solutions. Okay, so the one in the shaded part are the solution. I repeat, -1 and 3, 1 and -3, so I can rewrite here. So solution, -1 and 3, 3 and -2, 1 and -3, 2 and -4. So these are the solutions. Okay, this was problem number 30. The last problem, 31. Is -1 and -5 a solution of the inequality y equals so -1 and -5 y greater than -x minus 1. So in order this to be a solution, must satisfy this. So is -5, I put a question mark, greater than -1 minus 1. So this is y -5 and this is x minus 1. So again, -5 is greater than 1 minus 1, this is 0, so is -5 greater than 0? This is wrong because -5 is less than 0, so this is correct, is not correct. So -1 and -5 is not a solution of the inequality. So the answer is no, -1 and -5 is not a solution to y greater than -x and -1. Okay, also I have another set of problems from last week. Let me find that for you. So here you have texted me, I got help on the other half that you did not send for last week. So I assume that you have that problems. So these are 31 problems for week 2, and then next week I will send you a video for third week. Thank you very much and have a good day.